Thank you, Ashok, and welcome to this session in track 2. As Ashok has said, my name is Jürgen Wolf. I'm from Würth Elektronik. I'm from the circuit board department at Würth Elektronik, and therefore we're looking on these things about sustainable PCBs and materials. So what do I want to show you today? So first, a short introduction, why we're doing this. We will move on to alternative base materials. So this is not being printing, this is more like base materials. And then we'll go into efficiency in production processes in the example of inkjet technology, what we do here in the PCB technology. So basically everything what we do in part of the sustainability approaches is going to the global regulations and is focused on the 5 Ps, which we see here. That's like partnership, people, peace, prosperity, planet. And this is part of the UN Sustainability Development Goals, the so-called SDGs, where you have those 17 goals where all this different work is being based on. And especially here in the EU, we have the UE Green Deal, where we deal with the climate change, which is considered as an existential threat. And basically the 3 main topics here for us are that there's supposed to be no net emission of greenhouse gases by 2050, the economic growth should be decoupled from the use of the resource, and still no person and no place should be left behind. And these 3 topics basically have been transferred into our strategy at Würth Elektronik, so that we have to deal with the climate, so the production, the decoupling, and the social standards. And behind each topic, we basically, in our global and company corporate strategy, we have different topics where we want to work on. And I picked out 2 of these for today. One we will see later, the efficiency in the production processes, and our R&D activities towards alternative base materials. So when you look on the R&D and development landscape here in Europe, there are several approaches regarding sustainable base materials. There is like a cooperation in Sweden, Paper Shell, which is looking on it. There is a UE-funded project, Circle Paper, and those are looking on cellulose-based substrates basically for printed circuit board, and these could be either copper laminated like in traditional PCB manufacturing, or they will be printed with some kind of metal, for example with silver paste. What always is the same with these materials is that they are solderable with low temperature solder paste, and this is rather critical when it comes to market approach. A lot of our customers are not using low temperature solder paste, so this is something which has to be overcome when we go to future. Either the step that our customers in their solder equipment are using low temperature solders, there are a lot of projects in that direction, or those substrates need to be more temperature stable. And I picked out another one which is recently, like the last 1.5 to 2 years, gained just a lot of, I would say, focus due to the maturity of the product. It's called Soluboard, which is basically from a startup in UK called Shiva Materials. This material is basically a polymer-bound natural fiber cloth. So it could be either UJ or flax, and you have a polymer, a bio-based polymer surrounding it, making it a printed circuit board substrate. Interesting about this one is that Jiva could formulate the resin components so that way that it still could be flame retardant as FR4 epoxy, which is quite interesting for those biopolymers. It even is UL certified, which makes it very interesting for us to have a look on it, because a lot of our customers need the UL certified products. And when you look on it, it basically got a lot of attention all over the world, like companies, you see this here, this was spun by Infineon, and a lot of big companies, Amazon and so on, have a look on the material, and so we did as well. And this is our first test, basically what you did, and you see basically really what it looks like. You see those natural fibers embedded into basically some kind of polymer. And these were the first trials we did like 3-4 years ago. This was still, we had holes in it, but they were not through-hole contacted. It's basically just metal on top and on bottom, and you had to make the through-hole by sticking something inside the hole. But the biggest problem was Soluboard, the name comes from, the invention was to have a recyclable material to make the material solute into water. So you can basically recycle it by dilution it. The problem is when you put it into water and it gets rid of it, what do you do in printed circuit board manufacturing? A lot of our processes are water-based. So when we got in talk to them, they saw they need to change something, and that's what they did. They changed the formula resin, the resin of the formula, and adapted it so that